Hey guys, I wanted to put a video out there to help you with combinations with probability behind them. So this question is from Review A. This is question 5 and 8, 5A and 5B are what we're going to look at. So let's read question 5. It says, there are 12 people on the basketball team and the coach needs to choose 5 to put in the game. Now question A says, how many different possible ways can the coach choose a team of 5 players? Now, let's go ahead and assume, like we did the other day, that they can pick any 5 players. The position is not important, just 5 players. I know in basketball usually the position is important, but let's say it's not. So let's treat this as it's a C, a combination. And we're going to pick 5 players out of 12. So there's 12 total players, and we're going to choose 5 of them. So it looks like this. This is a C problem. It's a combination. 12 to choose from, and 5 we're going to actually pick. So it's a 12C5. If you work this out, I have the math here. It's 12 factorial over 12 minus 5 factorial times 5 factorial. If you work this out, do subtracting, crossing stuff out, you eventually get 792. So there's 792 ways you can take 5 people from the 12 players on the team and put them in the starting lineup. Now the probability part comes on part B. On part B it says if the coach chooses 5 players at random, okay, what is the probability that the team captain is chosen? So we have to plan this out a little bit. Whenever we do probability, the numerator is what you're looking for. The denominator is the total number of options. In these problems, the way they're set up and the way you'll see them on the test, the probability part comes after you find the total number. So in part A, we actually found the total number of players that you can choose randomly out of these 12. So the 5 random players, we already figured that out. That's the 792. But the numerator will be the captain and then 4 other players. Okay, because we want the captain no matter what. So what's the chances of that happening? So we would need the captain, he's 1 player, and then 4 other random ones. So if you work this out, I have the whole thing here, but if you look at that next part, the captain himself, he is a 1C1. Here's why. How many captains are there? There's 1. And we want to choose one of them. We want to, no matter what, we want to choose one. So it's a 1C1. There's 1 captain to choose from, and we're choosing one of them. That's why I have 1C1 there. If you work out 1C1, what do you get? You get 1. If you do all the subtraction and crossing out, you get the number 1. Okay? That's why I have it a little later. Then you're going to multiply that with 11C4. Now, the 11 is because we already have the captain. So there's only 11 other players to choose from. And then the 4 is because we have 1 player, we need 4 more to make the 5 starting players. So it's an 11C4. Okay, 11 to choose from, 4 that you need left to make the starting lineup. If you work that out, I didn't show it on the screen, but if you work that out, that's 330 different options. If you multiply those together, you get 330. 1 times 330. And then the denominator we already found out. That was the 792 from the 12C5. How many different ways are there to pick 5 people out of the 12 players? So if I divide that, you wind up getting 41.67%. What does this mean? This means there are 792 different ways to put 5 different people on the starting lineup out of the 12 players on the team. There are 330 ways you could pick 5 people and have the captain as part of that starting 5. There's a bunch of other ways where the captain's not part of the starting lineup, but I didn't care about those. I only cared about the ones that the captain was part of that lineup. So that's what the 330 is. And then when I divide it, that tells me the percentage of players, the percentage that the captain is going to be in that starting lineup. And it's a 41.67% chance. All right. Have a good day today. Finish up all the reviews, and then I'll talk to you guys on Friday.